Dear students, welcome to Module 3 Implementation Fabrics. In the last class, we have discussed about integrated circuits. So, in today's class, we will be going to understand programmable logic devices. Okay, what are programmable logic devices? Is nothing but these are also the integrated circuit. These are also the ICs which contain an array of AND gates. It contains array of AND gates as well as another array of OR gates. So there are three kinds of PLDs basically available. Three different variants of the PLDs are available. One is programmable read-only memory (PROM). Programmable array logics are available. Programmable logic arrays are also there. Okay, so how do we make an entry of information into these devices is nothing but through programming it is possible for us to enter the information into these devices. So basically users will enter the program in the form of electrically in order to implement the Boolean functions, in order to enter the Boolean functions based on the requirement. So PLDs can be programmed after manufacture to vary their function. That's what users can program electrically into these devices in order to implement the Boolean functions. Coming to programmable array logic, this is a programmable array logic is a type of programmable logic devices, PLDs. Okay, so what are this programmable array logic? What is a major difference between PALs and PLDs? Let us understand that. So programmable array logic, it has programmable AND array, programmable AND array, and fixed OR array. That means at the input side, AND gate array will be having programmable pins. At the intermediary level towards output side, OR gate pins are not programmable. That's why we call it as fixed OR array. It was introduced in 1970s. First widely used PLDs. PAL 16L8 was developed by Monolithic Memories. The device name is PAL 16L8, where 16 inputs and 8 active low inputs were there. PAL 16R8, this is L8 and then later one is R8. That means 16 inputs and 8 registered outputs. Earlier it was active low outputs, now it is 8 registered outputs. If you have a look at the diagram of this PALs, you can understand that at the input side there is a programmable AND array. Okay, programmable part is at the input side, programmable AND array, and here it is fixed OR array, fixed OR gate arrays. Okay, so that means fixed OR gate side there is no programming involved. At the input side towards the input of AND gates, programming is possible. Okay, so that is what you can have a look at this AND array followed by OR gate. There will be a D flip-flop at the output side. Here the feedback path is useful in order to implement the finite state machines. Okay, so coming to CPLDs, complex programmable logic devices. Here multiple PALs, taking multiple PALs into an IC is nothing but complex PLDs. So programmable interconnect is provided over here. It also contains flash RAM technology to store the configuration. You can see that AND array as well as embedded PALs, multiple PALs have been connected over there, and there will be an interconnect, programmable interconnect network is connected. Okay, so those are CPLDs. Apart from that, there are another variants called as FPGAs, field programmable gate array. It contains smaller logic blocks. You can see that multiple logic blocks are there on the board. LB, whatever you're seeing, LB, that is logic block. Embedded static RAMs are there connected over here. Thousands and millions of equivalent gates are there in order to implement this logic. Okay, field programmable gate array contains logic blocks, embedded SRAMs. So what is a logic block? If I take an example of Spartan 2, Xilinx FPGA Spartan 2, it contains lookup table plus flip-flops. As you can see in the diagram, LUT as well as flip-flop is a combination in order to generate a logic block. One LB contains this much of components. So too complex to program logic blocks manually. It is not possible for us to program each and every logic block. As you can see, there are multiple logic blocks on board. It is not so easy for us to program each and every logic blocks manually. That's why we will take the help of synthesis tool to map our HDL code to the logic blocks and program the interconnect. So we will be depending on synthesis tool to perform that. And the board is having IO devices at the end. IO, it provides a possibility, that is IO ports, to connect the devices for interfacing. So IO block, it contains a registered or combinational input or output, plus tri-state devices are also connected over there. So programmable logic levels, sleeve rate, input threshold are some of the parameters that comes into picture while designing these IO blocks. Okay, so that is about different types of programmable logic devices. In the next class, we will be looking at IC packaging and different types of PCB packaging that is available for the ICs.